8.3 Geometric Sequence and Series, page 426 through 429 in your textbooks. Concept 1, identify a geometric sequence. Well, what we have in a geometric sequence is a common ratio. It's a multiple that is the same every time. So in A, it's 6, 12, 20, 30, 42 is our sequence of numbers. I could always take A sub 2 divided by A sub 1, which is 12 divided by 6, which is 2. A sub 3 divided by A sub 2, which is 20 twelfths, which is 5 thirds. A sub 4 divided by A sub 3, 30 twentieths, which is 2 thirds. Those are not the same, therefore it is not a geometric sequence. As opposed to B, where it goes 256, 64, 16, 4, 1. Well, 64 divided by 256 is 1/4. 16 divided by 64 is 1/4. 4 divided by 16 is 1/4. Therefore, we do have a common ratio. What's happening every time is we're taking a fourth or dividing by 4, and that is our geometric sequence. All right, number 2, tell whether each sequence is geometric or not. Give it a quick try. Go ahead and pause now because I'm going to show the answer. All right, there we go. Number 2A, from -3 to -18 to -108 and so forth, you're just multiplying by 6. B is not a geometric sequence. All right, here we go. Rules for geometric sequence. A sub n equals A sub 1 times r to the n minus 1 power. A sub 1 is my very first term. R is my common ratio. Those are two things that you need. And you plug them on in and you get your geometric sequence rule. All right, here we go. Let's do it. So, concept number 2. When I look at this, I can say, A sub 1 is 5. My common ratio, how do I get from 5 to 15 to 45? I multiply by 3. I plug it into that formula right there. A sub n equals A sub 1 times the common ratio of n minus 1. A sub n equals, substitute 5 for A sub 1, substitute 3 for common ratio r, n minus 1, and there is my rule. Once you have your rule, you can find any term, 100th term, 12th term. In this case, they want us to find the 8th term. So I say A sub 8 equals 5 times 3 to the 8 minus 1 power, which is 5 times 3 to the 7th power, which is 5 times, let's see, 2,187. 3 to the 7th power, and when you multiply, you get 10,935. And voila, we got the 8th term there. Over here, this time I'm going to go up. A sub 1 is 88. Common ratio, well, I go 88 to -44 to positive 22. Well, it's the opposite, and you're cutting in half. So A sub n equals 88 times -1/2 to the n minus 1 power. And done. And then what I'll do is do the 8th term as well. So A sub 8 equals 88 to the -1/2 times -1/2, sorry, to the 8 minus 1 power, which is 88 times -1/2 to the 7th power. Well, -1 to the 7th power is -1 times 88 is -88. 2 to the 2nd power is 128. And then I'm going to just reduce that. So the 8th term is equals -11/16. Plug that in your calculator and you get 0.086875. -0.6875. Okay, well, there we go. You're going to do the same thing with number 4. Give it a try. I for some reason changed it to the 10th term, but I did the 8th term, so just make it the 8th term there. and pause it, and here we go. The answer for both of those are right there. Take a look, check it out. Once you have that, we're going to flip it on up, do the next page. Alright, and here we go. So, just going to show the graphing ones. Alright. Writing a rule given a term and a common ratio. So, one term in a geometric sequence is a sub 4 equals 12. The common ratio is 2. Write a rule for the nth term and then graph the first 6 terms of the sequence. Alright, so I know that a sub n equals a sub 1 times r to the n minus 1 power. So if I substitute to the fourth term, I know it's a sub 4 equals a sub 1 times 2 to the 4 minus 1 power, and I just set it equal to 12. So 4 minus 1 is 3, so I got a sub 1 times 2 cubed equals 12. 2 cubed is 8. 8 times a sub 1 equals 12. Divide by 8 to both sides. A sub 1 equals 3 halves. Take that 3 halves, take your common ratio 2, write it in the formula right there, and we got our rule. So, then, my first term is 3 halves. Okay, my second term, all I do is take 3 halves and I multiply it by 2, since my common ratio is 2. And I get 3. Take 3 multiplied by 2, I get 6. 6 multiplied by 2, I get 12. 12 multiplied by 2, I get 24. And 24 multiplied by 2, I get my sixth term of 48. And I graph them right there and you can see. Now, these geometric sequences are really representative of a exponential function. So it's going to go and shoot up. This is like exponential growth. Again, we are not going to connect the dots here, so just leave those points there, and that is the sequence of numbers. Go ahead and give number 6 a try. This time you have a sub 5 is 32. Your common ratio is 2/3, which is going to be exponential decay this time. And you're going to find the rule and the 6 terms. Go ahead and give it a pause, give it a try, and here is the answer. Check it on out. And I'm going to go ahead and walk you through number 7 here. I'm going to move this. Number 7. We have 2 terms. We have a sub 2 is 12. A sub 5 is negative 768. We're going to write a rule for the nth term. Well, we don't know the first term or we don't know the common ratio. So what I'm going to do is take this, basically do a substitution of systems of equations with this. Alright, so a sub 2 equals a sub 1 times r to the 2 minus 1 power. That's a sub 1, and I'll set it equal to 12 here. So it's a sub 1 times r equals 12. And if I solve for r, if I solve for a sub 1 and I divide by r to both sides here, I get a sub 1 all by itself, which is 12 over r. What I'm going to do is I'm going to take that a sub 1 and I'm going to use this 5th term right here. And then what I'll do is just get one variable r to solve for. So a sub 5 equals a sub 1, 12 over r, which we just solved for, equals r to the 5 minus 1 power equals negative 768. Alright, so simplify. 12 over r times r to the 4th power equals negative 768. Divide. When you divide like bases, you subtract your exponents. I get 12r cubed equals negative 768. Divide by 12 to get r cubed all by itself. R cubed is equal to negative 64. I'm going to take the cube root on both sides. When I do that, I get isolate r all by itself, and I get negative 4. Okay, so I solve for r, and if I go back over here, right, and put in r, I get 12 over negative 4, and that's negative 3, and now I can solve for my first term, a sub 1, and if I have both r and a sub 1, then I can write it my rule. A sub n equals negative 3 times negative 4 to the n minus 1 power. So now I have the rule Okay, there's number 7. Go ahead and flip the page and give it a try. I'm going to show the answer here, so go ahead and pause and work through the solution. Alright, here we go. Number 8, you should get an answer of a sub n equals 5 times negative 2 to the n minus 1 power. Alright, here we go. The next concept is the sum of finite geometric sequence, which we are going to basically do is the series, right? A series is a sum of a set of numbers. So in this case, since we're using exponential growth, these are going to be, or using an exponential model, it's going to be pretty large numbers, or really small numbers potentially, but most likely really large numbers here. And what I'm going to do is work you through these problems. Alright, and S sub n, which means we had the sum of the number of terms, is equal to a sub 1, our first term, times the quantity of 1 minus our common ratio to the power of the number of terms that we have, all over 1 minus our common ratio. So, when I use that formula right there, I need my a sub 1, I need my n, the number of terms, and I need my common ratio. So, to find a sub 1, all I have to do is plug in 1 into my rule. So I have 4 times 3 to the 1 minus 1 power, which is 4 times 3 to the 0 power. Anything to 0 power is 1 times 4 is 4. Now this one happened to follow the perfect rule format, so I could have just looked there in this question, but you can't always do that. Common ratio is 3, and your number of terms is my upper limit, 10. So S of 10, the sum of all 10 terms, are 4 times the quantity of 1 minus 3 to the 10th power over 1 minus 3. Okay, and when I do that, I get 4 times, well, it's going to be negative 15,624 over negative 4. No, negative 2, sorry. And then what I would do is change those negatives to a positive. I'd cross cancel. 4 divided by 2 is 2. Multiply 2 times that 15,624, and I get 118,096. So the sum of all 10 terms is 118,096 is the answer. Alright, last one, number 10, give it a try. I'm going to go ahead and show this answer here. Pause. Here you go. There is the answer for that last one. The sum of the 6 terms, is 9,765.